Okay, so here we're going to consider Rolle's theorem. So Rolle's theorem said provided the function is continuous and differentiable on the interval, and that the endpoints, that there are two function values that are same on that interval. In this case, we're just going to evaluate the function at the endpoints -1 and 1, provided these two function values are the same, that there must be some time at which the derivative is equal to 0 in between those two, or there's a horizontal tangent in between these two x values. So f of -1, plug in -1 in that numerator, you get 0 over -1, which is 0. And f of 1 is equal to, same thing, 1 minus 1, so that's 0 over 1, which is equal to 0. Since these two function values are the same, we can take the derivative. So let's just do the derivative real quick using the quotient rule. So here's the derivative using the quotient rule. Low d high minus high d low over low squared. So we get x squared plus 1 and x squared. So therefore, we're trying to find when the derivative is equal to 0. So we said x squared, or the derivative, equal to 0. Notice that I don't do x squared equal to 0, because that'll be when f prime of x does not exist. This is the case in which f prime of x equals 0. Well, there is no time in which x squared plus 1 equals 0. So therefore, there is no x values. So it looks like we have an issue. So let's take a look at the graph, and maybe that'll resolve our problem here. Here's our graph on the interval from -1. Here's -1 comma 0 to 1, 1 comma 0. So right here, here's our secant line connecting those two. And what Rolle's theorem says is, provided the function is continuous and differentiable on the interval, and the function values, there are two function values that are the same. At this case, at the endpoints, the function values are the same, 0. There has to be some horizontal tangent in between -1 and 1 that is also equal to 0. Well, you notice not only is our function f not continuous, but it's also not differentiable. Whenever a function is not continuous, it's not differentiable. So therefore, we should never have considered Rolle's theorem, because on this interval from -1 to 1, there is a vertical asymptote, namely at 0, because x equals 0 is a vertical asymptote. So therefore, we can't apply Rolle's theorem because the function is not differentiable at x equals 0. So therefore, we shouldn't have even considered this problem. First thing we should have done is considered, is there any points at which this function is not differentiable? You can do it two ways. First, check continuity. Is there any values that make this function discontinuous? Sure, when x equals 0, is 0 in this interval? Yes, so therefore Rolle's theorem shouldn't have applied. If you didn't catch it here, you could have done the derivative. Also check, is there any time at which the derivative is not defined? In this case, when the denominator is equal to 0, which gives you the same number, 0. So this shows you that it's not differentiable. Checking for extraneous values in the denominator, or excuse me, zeros in the denominator, gives you it's discontinuous, and discontinuity implies not differentiable. So therefore, since, we're just going to write out a little blurb here. So here's a little blurb here. Since f of x is not continuous nor differentiable at x equals 0, then we cannot apply Rolle's theorem on the interval -1 to 1. And also, if you look at the graph, it clearly doesn't look like there's any tangent line that you would draw ever on this interval from -1 to 1 where the tangent line would be horizontal. So there you go.